Hello and welcome. Thank you for taking time out and being here today. I'm going to give a couple of minutes for the last few people to log in and join the webinar. This gives yourself some time to grab a coffee, some water or a beer, depending on your preference. I'm Miguel Coelho, a ventilation engineer and business development manager at the BBE Group. I've spent almost a decade in ventilation engineering. And we'll be joined later by Hendrik Botma, our Chief Technology Officer. An update to VUMA was released last week, so please head on over to VUMA3D.com to grab a copy of the latest version. Just some housekeeping. Everyone will be muted for the session. We would love to hear from you, so please send us your questions or comments using the questions panel. There will be a 30-second demo of how to send questions during this webinar. There will also be a survey at the end of this webinar, which will take a couple minutes to complete, but will provide us with valuable feedback, so if you could please assist us. If you miss anything, don't worry. We'll be sending the on-demand recording when it's available. Remember to follow us on LinkedIn or Facebook using the tag VUMA3D. I can see already a couple of questions coming through, and I can also see most of the people have joined in. So without further ado, here we go. Welcome to the July webinar for VUMA-network. For those of you just joining us, I'm Miguel Coelho, Business Development Manager and Ventilation Engineer at the BBE Group, and I'll be joined by Hendrik Botma, our Chief Technology Officer. We've also got an updated photo now. Just a reminder to download and install the latest full free version of VUMA. Service Pack 2 was released last week, so please head on over to VUMA3D.com to update. Today we'll be discussing recirculation, design criteria, blast clearance, Whatifs, which is quite a powerful tool, and thermal subdata. Here we go.
Your control panel is in the upper right-hand corner. If you cannot see it, it may be collapsed. To expand the control panel, click here to view more options. Another way to communicate or ask questions of the organizer in session is by using the questions pane in the control panel. Simply type in a question and click send. Your questions will be sent to the organizer directly without other attendees seeing them. Thanks for watching this GoToWebinar attendee quick tip video.
So here we have a typical sub-level open stoping mine. It's got two ramps going down, one indicated in purple, the other one in red. We've got some fans coming off the fresh air raisers in tight circuit, ventilating some of the development ends, indicated by the turquoise. And what tends to happen is, while you're modeling, you might forget to check for recirculation. And recirculation can impact your blast clearance time, heat pickup in your mine. So it's always good to check for recirculation. So here I've done a full solution. And to check for recirculation, you go to the Solve tab and you click Recirculation. VUMA will run through, check check if there are any recirculation paths, and if there are, this form would pop up. Depending on the number of recirculation paths, they would all be listed here. So here we have this recirculation path. It's got 11% recirculation. If I drop it down, it tells you the path that it's using. And in the background, each recirculation path would be given another color. So here you can see this recirculation path. And what's happened here is the fan has been placed incorrectly, been placed in its own return path. So to fix that, you disconnect there, you turn on the nose, drag this over, and merge it, and escape now, close that, do a full solution, and I'll check for recirculation again. You'll see no path detected. So remember, when you're doing your solutions and you're starting to calibrate your model, every now and then do check for recirculation. That could hinder your progress in calibrating the model. So you've calibrated your model, and during your model calibration, you adhered to a design criteria. So now you want to check that you meet the requirements of your design criteria as per your company's ventilation standard or per your study's ventilation design criteria report. So in VUMA, under libraries, you can go set up the design criteria. And here you can set up this field here, you can set up the maximum temperatures for wet bulb, dry bulb. This field here is the velocity ranges. And in the background, the model was already started highlighting when the velocity is out of design, when it's in the critical velocity or the terminal, the critical velocity where water blankets can occur. If you exceed your temperatures, any of these temperatures here, if you exceed the velocity and the temperature, it'll go black. If you exceed your design reject, and blue means it's all good. These fields here, open them up, it shows you which ones are exceeding, which of your my developments are exceeding the velocity setup. So let me set up some parameters here. The intake we can keep at 30, the return terminal we can change to 33. Development faces, we want to keep them below 29. There is no slopes in this model, or slope branch types, so you could just make it 29. And your design reject 29. In terms of dry bulbs, set that up to 33, return 35, development 33. Again, you would set up these fields according to your design criteria. Run reject 5. And those using DWBGT as a parameter, you can set that up as well. And velocities, if you want 0.25 meters per second is the minimum in your face velocity. Sloping, don't have, but you could set it up as 1. You want your intake tunnels to be a minimum of 7 and a maximum of 12. In this case, we don't want them to go over 7 due to tracking, and we don't want it to drop below 1. The returns, you can also keep it at 1, and we don't want it to exceed 10. An intake equipped shaft, so that's a shaft with a conveyance, like a cage, hoisting people or rock winders. You don't want it to exceed 10, and minimum 5. And an unequipped shaft, we try and keep at 12 to 15 due to economics. In your return shafts, we push to 22. So now you'll see the model is highlighted. Yellow means my velocity is exceeded, and if I can also do this. I click here, and say take me to that branch. I can hover on it and see what's wrong. Now at a glimpse, you can see where your problem areas are in your mine. These that are exceeding the temperature is saying that wet bulb's 29.5, which is fine, since we want to be below 30. The dry bulb's 33.1. You'll see if I start increasing that limit, more and more branches will go blue. A very useful tool. At a glimpse, you can see all the problems in your mine and go troubleshoot them. Here you've got shafts, intake air, they're running at 20 meters per second, and we stipulated somewhere between 12 and 15. These are actually the top of attached to a bulky cooler and fans, so you could maybe overlook that value since the fans are assisting it. Okay, thank you. I'll now be taking you through setting up a blast clearance. A couple of things you need to check before you can start is first, you need a full solution or at least just an error solve. So I have a full solution. Next, we need to check that there are no reverse flows, as that will hamper your blast clearance time. So I click there, fix reverse flows. It picks up those few. Once those are fixed, I solve again. Full solution. You double check that again for reverse flows. Nothing found. That's good. Check for recirculation as well. No recirculation found. So now you're ready to start your blast. So under solve, you get the blast settings. So I would now go to settings. And this is where you can set up your blast. You can say my clearance limit for NOx must be 3 ppm, for carbon monoxide 30. If you're monitoring spiral dust, you can set that limit as well. You can set your occupational limits. VUMA then can tell VUMA that after 3 hours it should stop solving, or simulated solving, so it can stop. It should warn when the blast exceeds 3 hours, and you can set up your reporting interval. Depending on the type of resolution you want in terms of incremental increases, you can bring it down all the way down to a second or increase it above 60 seconds. We tend to keep it at 60 seconds. You can show smoke trails. And here you can set your playback for your playback fields according to your requirements. Once this is set up, you say OK. I haven't set up a blast yet, or blast in the stopes, in the development ends, and only development ends or stope branch types can get blasts. So a quick way to add a blast is to add to all development ends. So I just go click, add, pick your explosive type. Typically it's emulsion. You'll know your charge factor from your mine. You will then say, I know I use 250 kilograms per end of emulsion, and you'll see that the phase advance then updates accordingly. Once you've done that, you say OK. You get a confirmation box saying it's been added. If you want to visually make sure, under display billboards, I've got all the vehicles, but if I go set up my billboards under configure billboards, then turn off vehicles and switch on explosives. Make them a bit size. So you can see all the ends that are explosives indicated. What you can further do is under the home tab, and this button, you can also set blast monitors. So you know I want to clear my blast at this point, at that point, at this point. It's all my returns. And that point, you set them up, say escape, and then you can proceed back to solve and say do a blast clearance. VUMA does the initial calc, and then it starts solving. It shows you the CO values, still over 500. NOx has already dropped below 15, or is around 15, and dust is starting to drop. And in this box here, you can see the blast monitors you set up, what the velocity was in those branches, what the CO and NOx and dust levels are in those branches that you're monitoring. You can see VUMA is progressing with the solve. It's now 40 minutes. There it's solved. You can have the legend shown. So anything above 1,000 will show as red. Branches that had blast contaminants and have cleared will turn purple. Branches that never received any blast contaminants will stay unaffected. The animation playback's been set for the CO. Now I can click play, and you'll see those branches that are purple are cleared. Orange is between 100 and 1,000. And as the playback plays, you can see how blast clears. You can also see the branches that are still with contaminants have this graphic rendering around it. Then you can see it clearing. There it goes, just the return. And you have this little trail here taking its time to clear, which you can go troubleshoot if you want to improve your blast clearance time. Maybe you're trying to target 45 minutes or half an hour. You can also switch to NOx playback. Again, show legend if you want, unless you know the legend. There you can see it's starting to clear. There it goes, clear. Okay, we also have a summary. This tells you the last branch to clear is the decline 2 branch, and you can go to it. So okay, that's the last branch to clear. What's quite handy is that any branch that received contaminants will have a trend. So if I go double click on that, you don't have to do that anymore. If I go click here under blast, here you can see the graph and it shows you the time. So this one cleared in about 10 minutes for NOx. And see how it took about 10 minutes. You see it peaked and then sort of dropping down. If I go to another branch type, you can just resize this panel according to what you need. I can go here. You can see the first wave of the blast came through, cleared, and then the second wave came through and cleared. If you want to and you want to take this data to Excel, you say right click, copy data points to clipboard, and then go into Excel and paste it and set up your own graphs as you need. And there you have it. That's how easy is that to do a blast in VUMA. Thank you.
The first topic I will discuss today is Whatifs. Whatifs has been around in VUMA for a couple of years, but we thought it would be a good opportunity to delve a little bit into it. It really is quite an easy tool to use, so let's check it out. So under our examples, there is a Whatif model loaded. Very small mine, 2 decline rams. I'll put it on intake and return. And we have 2 coolers on surface. Okay, so what is a Whatif? Basically, it allows you to edit a few attributes of any type of branch, whether it's a control manager, like a cooler, where you want to increase or decrease the duties, a fan, where you want to speed up or stop a fan, or a tunnel, where you want to change attributes like the friction factor or the sizes. So what you do is you go to the branch where you want to change a parameter, you edit it, and all you do here is you mark it for a Whatif. So whatever branch in your network you want to play with, you mark it. Once you have set up or marked these branches, you go to libraries, Whatifs, and here you have to define your different options. Now in the example over here, we have marked both the 2 BACs on surface, which you see over here, and I can now go and edit those specific branches individually. So as you will notice here, I have made my first Whatif 5000 kilowatts. So if I double click on a branch, I can go and edit it. Here it's 2500. Maybe I want to say this one will do 3000, and this one I double click will do a duty of 2000. Okay, giving me that total of 5000. I have another option here where they will both do 1 megawatt, and then here they do no cooling. Once you have defined the changes in the different Whatifs, you do a full solve over here. Basically what will happen is VUMA will do a solve using these parameters, another solve using these, and then a solve using these. Quick note, you are not limited in the number of branches that you mark for a Whatif, nor are you limited by the number of Whatifs. So you can have a 5,000, 4,000, 3,000, 2,000, 1,000, it doesn't matter. Okay, so we've done our solves, it came back, no big problems. We go okay, and what we will do now is we'll put the dockable panel here on the Whatif results tab, and if I hover over a branch, you will notice instead of a single value, graphs appear. And these graphs, the blue line is the wet bulb. Now remember what we're doing is we're decreasing the output duty or the duty of the coolers, so it goes from 15.9 to 20.1, and the orange line is our volume flow. Nothing really big changes in there as we would expect. On these graphs you can customize their appearance, so we right click, customize, we go to the Whatifs. Like before, you can choose what you want to see. Maybe we want to add the dry bulbs as well. Let's just see the effect of that. So we'll click here on OK. And now the dry bulbs appear as the red line. And you will notice I can go anywhere in the network and see the effect. It's not only on the Whatif branches, I can go all the way to the bottom here and see the net effect. You would have noticed if you don't like the step lines, you can also make it a column or a bar chart, and then you can compare the values like this. Okay, so as we decrease the duties, you see the resulting effect over the network. If I wanted to add another parameter, maybe this fan over here, I want to, in conjunction with changing the temperatures, also adjust the volume flow. I mark it as a Whatif, so normally it does about 300 cubes. I go back to my library Whatifs over here, and now this fan is added here. So the default value will be the 300. Let's say when we have no cooling, I want to increase this to 500. I click on the OK button. Oops, that's one too many there. I click on the OK button. I rerun the full solve. Okay, everything is fine. If I now hover over a branch, you'll see the changing in velocities, the green bar, which is obviously because I increase the velocity or the total volume in the last scenario. Like I said, very easy to use. Once you're done with the Whatifs, you just go back to your normal hinge. You carry on solving, making your edits, and it is as it was before. Okay, I see there's one question relating to how to get these graphs or data in your own PowerPoint presentation or Excel. Now, if you just need the graph, you can simply right click and say copy graph to clipboard, then go to Excel or PowerPoint and paste this image. If you prefer, however, to create your own types of graphs, you can go back to Libraries Whatifs and then go to the Results tab over here. The data here can be sorted. You can select one row or multiple rows. Right click again, say copy, and back in Excel you can paste these values and then create your own graph. So for instance, if I'm interested in wet bulbs, I'll select this one, this one, this one, this one, click on your insert, choose for instance a column graph, and you've got your own graphs. Next up, I want to talk about the thermal and contaminant tools that we have in VUMA. Now, if you go to the Tools tab, you would notice the Thermal or Contaminants tab over here. What often happens during the modeling process is that at some point, especially during calibration, you realize that you neglected to add or compensate for certain heats, such as linear heat, often used for lights and cable, pipes that might be in your intakes, contaminants such as dust or gas sources. And it can be quite painful to now go to each and every individual branch, editing the branch, and then going to the subdata tab over here in order to add the specific subdata. So to make this a bit easier, this thermal tab over here, clicking on it, allows you to add or remove any type of subdata to your network. You start off by deciding what type of subdata you want to add, maybe user heat in your tunnels and maybe winches in your stopes. Once you've added the type, you choose, do you want to add them or remove them? In this case, we want to add them. And then here you can decide, do you want to add the subdata only to intake branches, or do you want to also add them to dedicated return branches and service return branches? Under normal circumstances, you don't want to bother adding them to your dedicated returns and into your intakes, and if you model it, service return branches as well. Now when you click on OK here, it will ask you for each type that you've added, what do you want? So typically for our user defined, we will add a linear heat. As mentioned, this can be for lights and cables. A good value is 0.05, and being electrical, typically it will be a dry heat. Next up will be our winches. Remember, we're adding winches to our stopes, and let's say there is 200 kilowatts of winches doing a moderate duty. So if I go now to any of my tunnels in the network, this data will be added over here, and I can go to one over here. It will contain that subdata as well. To achieve the opposite, i.e. to remove all of this, you can go to thermal, choose the user heat, and say remove. Once again, from which types do you want to remove them? And if I go to any of these tunnels now, that will have disappeared. Okay, makes it a lot simpler to work with. You can follow the exact same principles for contaminants. So if you want to add dust or gas to one of your airways, this is the way to quickly add it. Just a secondary note over here, if you've made a multi-selection prior to going to this tool, you would notice that only the tunnel block now is enabled, and this limit to only selected branches is automatically checked as well. So I can now say just add user heat to the selected branches. Once again, it gives me the option, I'm just going to call it ABC for now, to add or specify the value I want to add. Click on accept changes. Now if I go to these branches, they will have these values, but if I go to one of these, because they weren't part of the selection, they are still empty. Okay, very useful tool. Very good to remember and to employ it on your models as well. Thank you for joining us. This concludes the third episode of our webinars. If you have any questions, please drop us an email on info@vuma3d.com, or you can follow us by searching LinkedIn or Facebook using the keyword VUMA3D. As always, we are looking forward to your feedback and suggestions. Happy modeling. Bye-bye.